Hello and welcome to the C++11 Beginner Tutorials by Gamer2Creator. I'm Chris. Alright, so this is the next video after references, and we are going to talk about pointers. As I said, pointers and references have a lot in common, but they do have some differences, and we'll cover many of those in this video. Okay, so here we've created a foo. We're going to make this a regular variable instead of just a temporary. And we're going to pass it by a reference. Those need to go away. So here we've created a foo. We're passing it as a variable. It's being passed by reference. And then it's going to do some stuff with foo here. Now there's one other thing that you can do, and I'm going to cover it first in main, foo pointer. And I like to use a prefix with a P, which you can read this sort of like you break it down into English. This is a pointer to a foo. And I always do that. It's just a choice that I made, a style that I use, and it works well for me. You can do whatever you want, but of course I'm going to suggest you do what I'm doing, at least at the start. So here we've declared a pointer. That's what this little star symbol means. Just like the ampersand means reference, this means pointer, and it's a pointer to a foo. Just like a reference references a foo, a pointer points to the memory location where a foo object should be. Doesn't mean it'll be there. You have to be sure that you know what you're doing with pointers. And I'll get into that soon. Alright, so we've declared our pointer, but we don't have anything assigned to it. What we need to do is get the memory location of our foo that we wish to point to and assign that to our pfoo variable. So we use the equals sign, and now we're going to try to say equals a foo. Will this work? No, it will not. Because this is a foo object, and the computer has no idea how to turn a foo into a foo pointer until you tell it to get the address of the foo object. Now this is not a reference. In this context, the ampersand symbol means the address of. This means give me the address of whatever variable is to the right of me. The ampersand symbol is context sensitive in many ways. For example, when it's next to, or let's say between, a type and a variable, it means reference. When it's just next to a variable, it means address of. And then there's also the context of and the bitwise and if foo, I don't know, let's say, I'll just say true and true. In this case, the ampersands mean and. I believe this is the bitwise and. So you have to be very careful with these ampersand symbols and understand that they mean different things in different contexts. So here we've grabbed the address of our foo. We've copied that address into our pointer. We're going to run the program and step over this, and you can actually see what looks like some weird code numbers or something. That is actually the memory address in hexadecimal of our foo object up here, because we grabbed that address and stuffed it into our variable. Now, it's important to note that while addresses are usually displayed in hexadecimal, which always, or at least with C++, is usually displayed with 0x and then the hexadecimal number. The 0x means this is hex. That hexadecimal is really just another numbering system. So you can actually think of this as just another way of displaying a plain ordinary number. Every address is just a number, like 1264, something. And that is a location in your memory somewhere where data is stored. And it can be, it actually addresses just 1 byte, but your data can be several bytes wide. So we've gotten our pointer, but what can we do with a pointer? Well, first let's add a little something here. We're going to add some data. We're going to say int m width and int m height. Oh my gosh, that's embarrassing. All right. We're going to take in a int width, int height. We're going to initialize. Well, I'll finish this here in a second. Okay. What I've done here is I've created 2 integers in the foo class, width and height. That's very common for 2D graphics, things like that, width and height of screens, width and height of a sprite or an object, or even a position in X and Y. So I've created that foo, I've initialized it to 800 and 600. I've gotten the address of it, and I've sent that address to some foo function. So once we get here, we'll jump up to here. This variable itself will be copied. Even though it's a pointer pointing to this variable, only this is being sent in and only this will be copied. So we have our pointer to a foo, we copy that pointer, and then we're going to do some stuff with the object it points to in this function, though I haven't wrote that code yet. But I want to prove to you that we have gotten the address, and you can actually see in the debugger the address is here, and you can actually see the values of the object it points to. The width and height of the foo that we're pointing to, which should be the same as this one since we're pointing to this one. So right here we're going to step into this function and step over, and you'll see that this foo is the same address as this foo. 04AFC14, 04AFC14. So we've passed a pointer into here. While we have copied the pointer, the object it points to has not been copied. And yes, I know this is complex. This is what makes C++ complex. This is it. This is the hardest thing about C++ in a lot of ways. I guess there may be other things that are pretty hard or harder, but a lot of languages don't allow pointers at all. because of their error proneness. They're hard to use or easy to make very disastrous bugs with if you don't use them properly. However, can you think of a cheaper way to reference another object within a computer than just storing its address? That is about the cheapest way that you can reference another object is by its address within a computer. And that's why C++ can be very, very fast. Other languages use other techniques which do a lot of the memory management legwork for you and help to prevent you from making mistakes, like writing to addresses that you shouldn't have and overwriting things that were important. For example, some languages use reference counting mechanisms, and as long as there's at least one reference to an object, that object will still be alive. And once that count reaches 0, that means nowhere does your program reference that object in memory, and then it is freed or deleted. Others will use garbage collection. It's like another little program within your program that runs in the background and looks for objects that are no longer referenced anywhere and then frees those up. Both of those, as you can tell, are far more expensive than just storing a memory address. So let's get down to the nitty-gritty and use this pointer. So here we're going to get an aspect ratio. We're going to cast the width and height of our foo object that we pointed to in pfoo, and we're going to get its width variable. Well, how do you do that? So if I do a dot right here, and this is in the way, if I do the dot right here like we usually do, nothing. If I do the dot down here, foo dot, oh look, popped right up. We got our width and our height. Do that. We could even assign this to a variable. And that's of course how you would do that with a regular variable or reference. But if you have a pointer, you have to use a different syntax, which is a pointer. It's that and then that, which is like an arrow, like a little pointing arrow. And it says, go get me the object that we're pointing to with this pointer and grab something. Grab one of its variables. So we'll say width. We'll divide that by and then we'll have our aspect ratio. And here I had to make sure to cast these to floats so that we can get our floating point results. And then I'll return a copy of our aspect ratio. I could have done this with a temporary, but this will work fine. As you can see, we get a 1.33 aspect ratio. And we're going to do this again, but we're going to step into this function and you can see it work. So you remember, because we passed our pointer with our address to foo, we're actually pointing to this object. And we're modifying this object. Well, actually, we're not modifying it yet. But we are reading from it. And we could modify it if we wanted to. And here you can see we grabbed the width and we grabbed the height, divided them, and we've got our aspect ratio. Now we could say, alright, if pfoo dot m, oops, that's a common mistake you'll be making. And that's why I put the P as a prefix so you know which to use, either the dot operator or the arrow. Now here we're going to check if height is, actually I'm going to say less than or equal to. Because if it's 0, this is actually an error, a divide by 0 error. But we don't want it to be negative either, so I'll say less than equal to 0. And we'll return 0 as the aspect ratio. But first we're going to set that just as kind of a dirty example of changing an object through a pointer. We'll say p foo m height equals 0. So if it's less than 0, we're going to bind it to 0. And I want you to see this happening in the debugger. So I'm going to pin that object. I continue on to, I didn't get hit. Width. If I change width to a value less than 0, we're going to trigger this if block. Alright, so we're right here. We're in this function. We've already ran through main. We called it. Now we're up here. We've got our pointer to this object over here. You can see that it's pfoo and it has an address. And then we can see that when you dereference that pointer, you can get its m width and m height. And we see that the values of that are the same ones we assigned down here. And you're going to get to watch as this one changes and this one changes. When we step over, oh look, m height was less than or equal to 0. So now we're going to set it to 0. You can see that it changed here. And when I go back to the stack here, come on, there we go. And when we jump back on the stack, you can see that this one has actually changed too. So we've actually modified this variable from this function through a pointer right here. We dereferenced the pointer here, we grabbed its field here, and we assigned it the value there. And then we're going to step over, return, and the program exits. So that's a very dirty, very quick introduction to pointers. I will highly suggest you practice with references and pointers. Play around with them, see what you can do. You can cause a lot of trouble, so be careful. Though the operating system should protect you from like hurting anything else, but no guarantees. Thank you for watching this video. See you next time.